topic, straight lines, learning area, coordinate geometry. Let us observe the equation of the line 3x plus 4. Let us now substitute different values of x to get the values of y. Let us now draw a graph for the given equation. We thus see that the equation of a straight line is satisfied by the coordinates of every point on the line. Let a straight line cut the x-axis at A. The angle theta between the straight line and the positive direction of the x-axis when measured in the anti-clockwise direction is the angle of inclination. Angle XAB is equal to theta and the slope is equal to tan theta. Thus, the slope of the line parallel to the x-axis is equal to 0 since tan 0 is equal to 0. Let us learn to find the slope of a straight line and the equation of a straight line in this lesson. At the end of this lesson, the students will be able to define slope and derive the formula of slope. Know how to find the slope of a straight line. The points are given. Know the condition for parallel and perpendicular lines in terms of slope. Know the different method of finding the equation using slope points form, 2-point form, slope-intercept form and intercept form. We know that a linear equation or an equation of the first degree in x and y represents a straight line. The equation of a straight line is satisfied by the coordinates of every point lying on the straight line. If the straight line L cuts the x-axis at A and y-axis at B, then the x-coordinate of A, that is OA, is called the x-intercept, and the y-coordinate of B, that is OB, is called the y-intercept of the straight line. Let us now look at the equation of a straight line in various forms. Since we know that on the x-axis, the y-coordinate of any point is 0, hence the equation of x-axis is y is equal to 0. Similarly, the equation of y-axis is x equal to 0. Let us now consider the line L to be a straight line parallel to the y-axis at a distance a from it. Then, the x-coordinate of any point on L is clearly a. Hence, the equation of the straight line parallel to the y-axis and at a distance a from it is x is equal to a. Let us now consider the straight line L, which is parallel to the x-axis at a distance b from it. Then, the y-coordinate of every point on L is clearly b. Therefore, the equation of the straight line L is y is equal to b. Let us now look at another example. Let a straight line cut the x-axis at A. The angle theta between the straight line and the positive direction of the x-axis when measured in the anti-clockwise direction is the angle of inclination. AB is the portion of the line above x-axis, hence angle XAB is equal to theta and the slope is equal to tan theta. Thus, the slope of the line parallel to the x-axis is equal to 0, since tan 0 is equal to 0. In case the line is perpendicular to the x-axis, then its inclination is equal to 90 degrees and the slope will be tan 90 degrees, which is not defined. Let us now determine the slope of a line joining two points. Let A and B be two given points so that the coordinates of A is x1, y1 and the coordinates of B is x2, y2. Let theta be the inclination of the line AB with positive direction of the x-axis. Let us now draw horizontal and vertical lines parallel to x-axis and y-axis through A and B respectively that intersects at C. From the right angle triangle ABC, tan theta is equal to BC divided by AC. We find that BC is nothing but BM minus CM and AC is equal to OM minus OL. Substituting the coordinates of A and B, we have slope M is equal to y2 minus y1 divided by x2 minus x1. The slope M can also be rewritten as y1 minus y2 divided by x1 minus x2. Let us now look at the slope of a line when the angle theta made by the line is acute. The slope is tan theta and it is positive. Similarly, when the angle theta is obtuse, we find the slope to be negative. Let us now determine the condition for two lines to be parallel. Consider two lines AB and CD. Let M1 and M2 be the slopes of these lines respectively. Therefore, the slope of the line M1 is equal to tan theta 1 and slope M2 is equal to tan theta 2. See that AB is parallel to CD and hence theta 1 is equal to theta 2 since they are the corresponding angles. Tan theta 1 is equal to tan theta 2, that is, M1 is equal to M2. We can say that if two lines are parallel, they must have the same slope. Now look at the condition for two lines to be perpendicular. Let AB and CD be two lines. If the product of slopes of two lines is minus 1, then the lines are perpendicular. In other words, if M1 and M2 are the slopes of two lines which are perpendicular, then M1 times M2 is equal to minus 1. Click on the proof button to view the proof of condition for two lines to be perpendicular. Thus, we may conclude that if the line is parallel to x-axis, then the slope is equal to 0. Also, if the line is perpendicular to x-axis or parallel to y-axis, then the slope is not defined. If the slope of a line is m, then the slope of the line that is perpendicular to it is minus 1 by m. Consider theta to be the angle of inclination of the line, given that the slope is equal to 1. Hence, tan theta is equal to 1. Thus, theta is equal to tan 45. Case 2. When the slope is equal to square root of 3, we have tan theta is equal to 60 degrees. Hence, the angle theta is equal to 60 degrees. Find the slope of a line which is parallel to a line whose slope is 1 by 2 and perpendicular to a line whose slope is minus 3. Given that the slope of the given line M is equal to 1 by 2. Hence, the slope of its parallel line is equal to 1 by 2 as we have learnt that when two lines are parallel, their slopes are equal. Case 2. Given that the slope of the given line M is equal to minus 3. Hence, the slope of its perpendicular line is minus 1 by M. that is equal to 1 by 3. Let us look at another example. A triangle has vertices at A as 1, minus 1, at B as minus 1, 1, and at C as 1, 1. Find the slope of the median through C. Let A, B and C be the given points. Midpoint is equal to x1 plus x2 divided by 2y1 plus y2 divided by 2 is the midpoint of AB. Substituting the values of coordinates, we have the coordinates of midpoint at 0, 0. Substituting these values in the equation of slope of CD, we have the value to be 1. Now look at this example. A is 2, 3, B is 0, 4, C is minus 5, 0 are the given points. Find the slope of the line passing through B at the midpoint of AC. Let us consider the midpoint of AC BD. We find the midpoint of AC by adding the coordinates for A and C. Thus, D is minus 3 by 2 and 3 by 2. Similarly, the slope of BD is y2 minus y1 divided by x2 minus x1. Substituting the values, we have the slope of BD to be 5 by 3. If the line joining A and B, whose coordinates are minus 4, 6 and minus 1, minus 3 respectively, is perpendicular to the line joining C and D, whose coordinates are 0, minus 4 and 3, A, then find A. Let M1 be the slope of AB, hence substituting the values of the coordinates, we have M1 to be minus 9 by 3, which is minus 3. Similarly, M2 is the slope of CD. Substituting the values, we have the slope to be A plus 4 divided by 3. Since the condition for the lines to be perpendicular is M1 times M2 is equal to minus 1, we multiply M1 and M2. On further simplification, we have A is equal to minus 3. Without using distance formula, show that the points P 3, 2 and Q 0, minus 1 are minus 3, minus 2 and S 0, 1 are the vertices of a parallelogram. Given the coordinates of P, Q, R and S, let us find the slopes of the given lines. The slope of PQ is equal to minus 1 minus 2 divided by 0 minus 3, which is equal to 1. Similarly, the slope of QR is equal to 1 by 3. The slope of RS is equal to 1 and the slope of SP is equal to 1 by 3. Thus, we see that PQ is parallel to RS. We can also see that the slope of QR is equal to SP, which is 1 by 3. Therefore, QR is parallel to SP. The opposite sides are parallel. The given points form a parallelogram. If the points 4, 1, minus 2, minus 3 and x, minus 5 are collinear, find x. Let A, B and C be the given points. Substituting the given values of the coordinates, slope of AB is equal to 2 by 3 and the slope of BC is equal to minus 2 by x plus 2. Points are collinear, slopes are equal and the slope of AB is equal to the slope of BC. Further simplifying, we have 2x plus 4 is equal to minus 6 or x is equal to minus 5. Now let us learn equation of a line. In general, the equation of a line is written in the slope-intercept form. The slope point two points form or the intercepts form. In this, let us learn the ways in which the equation of a line can be written and solve problems based on this. Now look at the equation in slope-intercept form. We know that the equation of a straight line with slope m and y-intercept c is y is equal to mx plus c. Now consider a line L with slope m and y-intercept c and theta be the angle made by the line with the positive direction of x-axis. We see that the line cuts off and intercepts c on the y-axis and hence the line passes through the coordinate a, 0, c. Let p, x, y be any point on the line. Now we draw PN that is perpendicular to x-axis. Draw AM perpendicular to PN so that it meets at M. Thus, the slope of the line is M is equal to tan theta. From triangle APM, we see that tan theta is equal to PM by AM. Also, PM is equal to PN minus NM and AM is equal to ON. In other words, Pn minus Nm by On is equal to y minus c divided by x. Rewriting, we have y minus c is equal to mx or y is equal to mx plus c. Hence, the equation of a straight line with slope m and y-intercept c is y is equal to mx plus c. If the straight line passes through the origin, then its equation is y is equal to mx. Similarly, for a straight line passing through the origin, y-intercept is 0. That is, c is equal to 0. Therefore, its equation is y is equal to mx. Let us now look at the equation for the slope point form. The equation of a straight line with slope m and passing through a point x1, y1 is y minus y1 is equal to m times x minus x1. Let the line be L that makes an angle theta with the x-axis and passes through the given point Q with coordinates x1, y1. Let the line be L that makes an angle theta with the x-axis and passes through the given point Q with coordinates x1, y1. But the slope is given to be m is equal to y minus y1 divided by x minus x1, or in other words, y minus y1 is equal to m times x minus x1. Thus, the equation of a straight line with slope m passing through the given points is y minus y1 is equal to m times x minus x1. We also note that if the straight line passes through the origin, that is, x1 is equal to 0, y1 is equal to 0, then the equation is nothing but y is equal to mx. We shall now look at the equation for the 2 points form. The equation of a straight line passing through the 2 points x1, y1 is y minus y1 divided by y2 minus y1 equal to x minus x1 divided by x2 minus x1. Let L be the given straight line that passes through the coordinates A, x1, y1 and B, x2, y2. Then the slope of the straight line is given by m is equal to y2 minus y1 divided by x2 minus x1. Since the straight line passes through the coordinate ax1, y1, then its equation is y minus y1 is equal to m times x minus x1. but m is equal to y2 minus y1 divided by x2 minus x1. Substituting this expression for m and simplifying the equation, we have the equation of the straight line L passing through the given 2 points as y minus y1 divided by y2 minus y1 is equal to x minus x1 divided by x2 minus x1. Let us look the intercepts form. Equation of a straight line which makes intercepts at A and B on the coordinate axis is given by x by A plus y by B is equal to 1. If the line intercepts x-axis at A and y-axis at B, then we have OA is equal to A and OB is equal to B, so that A has the coordinates A, 0 and B, 0, B. The 2 points form of the equation is given as y minus y1 divided by y2 minus y1, which is equal to x minus x1 divided by x2 minus x1. Substituting the coordinates for x1, y1 and x2, y2, we get x by A plus y by B is equal to 1. Find the equation of a straight line whose inclination with x-axis is 60 degrees and passes through the origin. The slope of the given line is m is equal to tan theta. That is, tan 60 is equal to square root of 3. Since the straight line passes through the origin, its y-intercept is 0 and hence c is 0. In other words, the equation of the straight line in slope-intercept form is y is equal to mx plus c, or y is equal to square root of 3 times x. Let us look at another example. Calculate the slope and y-intercept of the line 2x minus 3y plus 1 is equal to 0. Since 2x minus 3y plus 1 is equal to 0, 3y is equal to 2x plus 1, or y is equal to 2x by 3 plus 1 by 3. Comparing with y is equal to mx plus c, we get the value of m as 2 by 3 and c as 1 by 3. Hence, the slope is equal to 2 by 3 and the y-intercept is 1 by 3. Find the equation of the straight line which joins the points A minus 5, 1, B minus 2, 2. The given points are A minus 5, 1, B minus 2, 2. Hence, the equation joining the given points is y minus 1 divided by 2 minus 1 is equal to x minus 5 divided by minus 2 minus 5. Further simplifying, we have y minus 1 by plus 1 is equal to x minus 5 by minus 7. Thus, the required equation is x plus 7y minus 12 is equal to 0. Thus, the straight line 4x minus 3y minus 8 is equal to 0 pass through the point 2, 0. If the line 4x minus 3y minus 8 is equal to 0 passes through the point 2, 0, then x equal to 2, y equal to 0 must satisfy its equation. Substituting the given values, the equation is solved. Hence, 2, 0 satisfies the given equation. Therefore, the line passes through the point 2, 0. Find the equation of the straight line through 0, 7 and perpendicular to a straight line 5x plus 4y plus 11 is equal to 0. that the equation of the straight line is 5x plus 4y plus 11 is equal to 0. Hence, the slope of the given straight line is minus 5 divided by 4. Therefore, the slope of perpendicular line is equal to 4 by 5. Given that the straight line passes through the 0, 7, therefore, the equation of the line is y minus 7 is 4 by 5 times x minus 0. Further simplifying, we have the equation as 5y minus 35 is equal to 4x, and hence the equation of the straight line is 4x minus 5y plus 35 is equal to 0. Let us look at another example. A minus 5, 2, B 4, minus 6, and C 1, 7 are the vertices of the triangle ABC. Find the equation of the median drawn from A to BC. Let us now consider D to be the midpoint of BC. Using the coordinates of B and C, we get the midpoint of BC, that is D as 5 by 2, 1 by 2. The equation of the median for AD is y minus y1 divided by y2 minus y1 is equal to x minus x1 by x2 minus x1. Substituting the given values, we have y minus 2 by 1 by 2 minus 2 is equal to x plus 5 divided by 5 by 2 plus 5. Further simplifying, we have 5y minus 10 is equal to minus x minus 5. Thus, x plus 5y minus 5 is equal to 0 is the equation of the median. Find the equation of the line which passes through the point 3, 4 and makes intercepts on the axis such that their sum is 14. Click on the solution button to know the solution.